Okay. What is this word called as module what? Instantiation. Where does it come from? It comes from the word instance. You understand instance, right? Different instances of the same person. One person, second, same instance. When I call on the design multiple times, each time when I call on a design, I call that step what? I'm instantiating that design. Yes or no? Is this word clear? So when I say, did you instantiate that design? मतलब क्या इसको बुलाया क्या design को? I'm going to ask you that. In most literal Hindi, it's like इसको बुलाया क्या? Yes or no? So that you need to understand. Why is it important is, see, now you make a full adder. You know ripple carry adder, Ganesh sir asked you to revise, yes or no? कितना लोग नहीं किया? Honestly हाथ ऊपर रखो. कितना लोग रिवाइज नहीं किया? Honestly हाथ ऊपर करो. हाँ, अगली बार है ना ऐसा हाथ उठना नहीं मांगता, रिवाइज करने को बोला मतलब करके आने का. Okay? Now there will be a grade next time onwards. You understand that? Everything, all roads lead to Rome. Okay, so everything will lead to your grade. Let me tell you. So finally, that's why I said when you get an A grade, it is a true A grade. Means you've done everything well on this course. Understood? Please. I'm not picking on anybody. I expect you all to revise and come. It wasn't much. He was only asked you to two things to revise, right? Yes or no? Ripple carry adder and carry look ahead ना. कितना टाइम लगता है विकिपीडिया पे भी देखेगा तो आधा घंटा. Correct? I hope most of you all have done it. So ripple carry adder means what? One full adder feeding into another, Yes or no? Correct? So now, if I want to make that design, which will be again one of your other labs as homework that we will give, is you make a 4-bit ripple carry adder using what? One full adder. Suppose if on Sunday, if we finish it early, if you finish your full adder early, we'll take a crack at what? The ripple carry adder. Okay, TAs make note of that, please. Jainish kidhar gaya? Please make a note of that. That in case if we finish early, make sure what we will do. We will try the ripple carry adder. That will be your first mini project. Lo, पहले class में mini project खत्म. Okay. So what you will do is you will call on one full adder. First you'll write the basic design for full adder, which you will already do. Yes or no? Then what you'll say? Let me call on that in my top level module. You understand top level module? Correct? So you have the prime minister, then you have the chief ministers reporting to the prime minister, then you have the different ministers reporting to the chief minister, like that. So that type of design is called as a hierarchical design. Forgive me for my spelling. I'm slightly bad at English spelling, so forgive me for that if that is wrong. It's called as a hierarchical design, where it has hierarchy. All good designers use a combination of different styles of design. When you use hierarchy, that is typically called as structural design. You're making structures. Within each structure, please listen to me. When I use different levels, that is called structural design. Within each structure, अगर मैंने वो if else use किया, you know, if this then this, that type of design is called behavioral design. What is it called? Behavior. Where I am describing the behavior. Correct? Yes or no? So the three styles of design. First, again, there is no particular order. Please understand. You can say behavioral first, structural second, data flow third. Okay, मतलब any order. So structural, behavioral, and then you have data flow. Now structural means what? I'm one structure, I connect it to another, correct? At higher level, then they are connected, then this is connected to another design. Yes or no? ऐसा hierarchy में जा रहा है. Everybody's following me till here? Any questions? Guys at the back, you okay? Now, behavioral, suppose inside this, I am describing a mux. If S is equal to this, then X is equal to A, else X is equal to B. This is the behavior, na? Yes or no? Does this directly tell you it's a multiplexer? No. But it is describing the behavior of a multiplexer. Yes or no? Now, this is behavioral style. Data flow style, if I directly write X is A and B and C, I am writing concurrent statements. I am writing what? Concurrent statements where direct the value from the right hand side is flowing to the left hand side. Is this clear? So three styles. Structural matlab sabko साथ में organize करना. Behavioral means what? I'm describing the behavior. Data flow means what? I'm just writing concurrent statements. So X is A and B and C. So then I will say, suppose Y is X and A and C. I'm just writing hypothetical hardware. Okay. So when you write concurrent statements like this is what type of modeling? Data flow. Now, any good designer has to use a combination of all three. You cannot run away from that. So finally, when you will be a Verilog designer by the end of this course, you will have used a combination of all three. Now, your logical question, sir, which is better than the other? That's one logical question to ask. I will say none. Jaisi bimari vaisa ilaj. Understood? If anybody tells you one is better than the other, say no, boss. All of them are, depending on what. Can you wear leather shoes in the rain? No. Can you wear gumboots in summer? No. You have to understand. Depending on what is the type of design, you have to apply it. Clear? Then you remember that we wrote this equation. Output is equal to cell question mark. If that output was not of a reg type but was of a wire type, then वो always के बाहर आता था, yes or no? Then I would have written output is cell question mark A B. Where output is not your reg type, output is what? Wire type. Then this becomes data flow. But don't think about अगर मेरे को ये स्टाइल में करना है, कुछ एडवांटेज नहीं है उसका. फाइनली हार्डवेयर वो बनना चाहिए. Understood? Yes or no? You should be able to make that hardware. Good question. I'm saying that don't think unilaterally. You think three-dimensional. How can I use all three to my advantage? Don't fall in love with any one style. I'm telling you, dil tootega. Please understand that. In design and industry, never fall in love with a technology. Always it ends up in heartbreak. Just telling you. Because we have observed, let's say FPGA is excellent for one thing, but embedded one particular microcontroller is better for another thing. Always be agnostic. For this is good. For that is good. Am I clear? Okay. Now, is this clear? The three styles of modeling, yes or no? Okay. So your lab on Sunday will be what? First you will do a full adder. Then you will try one full adder using two half adders. Okay. Then you will do what? 4-bit ripple carry adder using full adder. That you can do? Yes or no? Okay. It's given. I want you all to do a little bit of self-learning. Start doing it. Copy this syntax. Copy this. Go home and now try and apply this syntax to what? One full adder using what? Two half adders. Use that word. One full adder using what? Two half adders. Uska syntax kya hai? For example, let me first explain it to you all. I'll explain basics to you all, okay? Left hand side is the module original, जो छोटा वाला module था ना, उसका port name. Okay? The right hand side, this one, when I say right hand side, the one in the bracket is the guy whom you are connecting to. For example, these are the original port names, yes or no? They will go here. Understood? Correct? Yes or no? This is your design you created, correct? Now I want to use them. Yes or no? I want to use them, correct? Say I'm connecting to X, Y, the select line I'm just calling M for now, and the OP I'm calling Z. Okay? The way we will write this is with respect to your previous syntax. Let's take a look. It will be dot X in bracket A. समझ में आया? Then comma dot Y in bracket what? B. dot select in bracket M, comma, dot OP in bracket anybody Z, open semicolon. Understood? Yes or no? This is the syntax. Why it is like this? Ask the guys who designed Verilog. Understood? Yes or no? See, you have to practice. Once you practice, na to haath aa jayega. Is this clear? Previously. This one. Now suppose if I have to write this, I will write dot A in bracket what? Let me give you a color combo also. Dot A, then it will be what? Dot B, dot select, and dot OP, comma, 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 close bracket, semicolon. Correct? Like this it will be. What I will write here, dot A will be X, dot B will be Y, this will be M, and this will be Z. Okay? Conceptually understood this? Okay? Now, how do I use this? Please understand. You have to first declare the guy in your design. उसको declare तो करना पड़ेगा ना, भाई ऐसा आदमी है. Correct? Yes or no? You have to declare it. Just declare him. Because in your VHDL, in your Verilog design, you already have that file that you created. Please understand this. First, please understand, everybody hear me out very carefully. First, let me actually draw it. It is much better rather than. So, first I'll write the design for the mux. Yes or no? That will be a Verilog file which is a .v. So Verilog is what extension? .v. Now, let me call this 2 muxes. This design is called what? 2 muxes. This will be another .v file. Another what? .v file in which I will just give the nameplate. I will just give the nameplate of what? The छोटा mux. बस. जिधर तुमने nameplate डाल दिया उसका, the guy when he's compiling the design, he will search. भाई छोटा किधर है? उसका .v file है क्या? Understood? Yes or no? Correct? Suppose you write question paper ना, स्कूल में question paper के साथ maps आता था. So it says the C map attached. So what is the first thing you used to go hunt for the map? Map नहीं है तो क्या automatically exam में हाथ उठा के नहीं? Yes or no? Or sometimes it says C data sheet attached. You Mumbai University, though we have single question paper, 8 questions. Life depends on that. But in school we had a map, right? Sometimes I don't know if ICSE कोई पढ़ा है क्या इधर? Map होता था ना? You have a map, right? So anyways, you have a map attached. So it says C map attached. Similarly here, the minute you declare that this guy, you declare this guy's nameplate. Say you declared it but you did not use it. The fact that you declared it also, he will go and hunt for the V file. कि is that there? क्योंकि he wants to see ना, आपने nameplate declare किया है. क्या declare किया है? Nameplate. अब भाई उसके घर में क्या हो रहा है वो भी तो मैं जाकर देखूंगा ना. वो तो अंतर्यामी नहीं बैठा है ना कि mux देखेगा तो he will believe it is called as a mux. Yes or no? I can call it a mux, but inside I can write the code of something else. You agree now? Who's given the name mux? I have given the name mux. Correct? So at the end of the day, I could mislead the design also. Yes or no? So he said, I don't believe a word of what you're saying. The minute you give the nameplate, what I want to see is, have you given me the internal design of that? Yes or no? If no, वो automatically error मारेगा उधर. Clear? Yes or no? Is this clear? Any questions? Okay. Now, see, these are basics. This is how you will visualize bigger designs.
Sir, we don't have to write the file name because.
See, you don't have to design. No. This is Verilog's way of saying you do declare his nameplate. Nameplate में क्या है? नाम आ गया ना? If you look at the declaration here, nameplate डाल दिया ना? Yes or no? Then comes the so. ठीक है? Just requesting you all. Now, so how will you use it? Dot first is who? The module's name, and then is your signal name. Clear? Yes or no? Agreed? TAs, will you be able to manage this? Fairly easy? Okay. Now, so, did you understand? अभी how do I say? First, bring the module name. अभी क्या उसको declare तो किया है, अभी इसको use करना है ना. Declare करके फायदा क्या है अगर use नहीं करने वाले? Everybody understands? I have to first declare him and then use him. Everybody following me here? So I declare him. So first I have to see who's that module. Then मैं वो module का नामकरण करेगा. See, I can use mux 20 times, right? Every time I need to give it an instance name, yes or no? I created an instance of mux, yes or no? I created an instance of mux, so I call him u1. Then I give out his connections. These connections you understand, yes or no? Yes? Similarly, u2. There are two ways of describing it. This is relational description, मतलब वन टू वन में डिस्क्रिप्शन दे रहा हूं. ए का कनेक्शन इधर जा रहा है, बी का कनेक्शन उधर जा रहा है. This kind of description, both are the same, both are the same. This is called as positional. This is called as what? Positional. मतलब क्या है? The first guy is A, so you will connect him to A. The second guy is B, so you'll connect him to B. Which one you think is easier to understand? फर्स्ट वन इज इजियर ना, बिकॉज पढ़ने वाले को भी बराबर से समझेगा. अंदर है बाहर है, अंदर है बाहर है. आई सजेस्ट यू यूज दिस वन. फॉरगेट दैट देयर इज दिस स्टाइल. डोंट कंफ्यूज योर सेल्फ. पहला वाला समझ में आया ना? पहला वाला समझ में आया? फर्स्ट, इनसाइड द ब्रैकेट इज वॉट, सॉरी, आउटसाइड द ब्रैकेट इज योर मॉड्यूल पोर्ट. इनसाइड द ब्रैकेट इज योर वायर और रेज. क्लियर? यस और नो? अंडरस्टूड दिस? Okay, ठीक है. Understood this? Any questions? Guys, so what did we understand? First, we understood how to create a basic design in Verilog. Simple. Then we understood an always, agreed? An always construct. Then we understood how to basically see a bigger design using what? Smaller design. This we will practice in the lab on Sunday. We will write. जब तक पहला थोड़ा Verilog पे हाथ बैठेगा नहीं ना, तब तक everything will be in thin air. Okay. My dad used to tell me swimming cannot be learnt on television. So finally, if you don't get inside the water, you'll never be able to learn swimming. So we have to get you started as soon as possible. That we will start on Sunday itself. Okay. Now, a few more rules and then we'll be done for the evening. Okay. Okay, for example, if I do not specify whether it is a wire or a reg, it will always default to what? Wire type. Please remember that. नहीं, बहुत उसमें बहुत important है कि अगर you want the output to be consumed inside an always block, it has to be what? Reg. वो आवाज करेगा ही करेगा. This is a fundamental of Verilog. Remember, don't forget that. उसका significance we will understand when we will do sequential and combinational together. Right now you are assuming कि why is this rule there? ठीक है, उसका मैं normal words में समझाता हूँ. यू नो, बचपन में बहुत मैं डैड के सामने मस्ती करता था ना. डैड क्या होता था, देख बेटा घूम फिर के तेरे को घर ही आने का है. समझ रहे ना? तो sequential construct is normally made for sequential circuits. You understand that? Sequential constructs is made for what? Sequential circuits. Sequential circuits मतलब क्या? Clock हुआ? Yes or no? Do you have a sequential circuit without clock? No. So sequential circuit में clock होगा. Finally कोई भी input या कोई भी output है, finally जाके कोई register के अंदर ही बैठने वाला है. काउंटर बोलो, रजिस्टर बोलो, कुछ भी बोलो, किधर जाएगा वो? रजिस्टर में. Yes or no? You can do all the jugglery, but finally it is going to go into a sequential circuit. Yes or no? You say counter, Johnson counter, up counter, down counter, register, shift register. Finally, what is all of that? It is a register, na? Yes or no? So what is he trying to say? Finally, it has to go in what type? Reg type. Now you see the significance. Now, one more statement, make a note of this. You can, please write the statement, you can create, or one can create, you as in any person can create combinational hardware using sequential constructs. You can create combinational hardware using sequential construct. इसका एग्जाम्पल हम लोग ने 20 मिनट पहले ही देखा है. That in an always block we wrote that na OP is, what is that? That is sequential hardware or combinational hardware? Multiplexer is what? Multiplexer is sequential or combinational? But I wrote it in sequential construct na. How? It's possible. It's possible. Please understand that it's possible. One of my favorite interview questions when I take an interview for any design company, when I interview, I ask, इन लोग को पूछा था, किसको पूछा था? तेरे को पूछा था, किसको पूछा था? तुम लोग को पूछा था ना कि why is sequential construct called a sequential construct? Simple. Answer is because it's the typical answer is because it is the things execute sequentially. No. Yes, it executes sequentially, but at the end of the day, a sequential construct is used to design what? Sequential hardware. However, you can design combinational hardware. Okay, it is possible. That is a well qualified interview answer. Understood? तुम लोग का प्रोफेसर क्या बोलेगा तुमको? Sequentially execute होता है, that's why it's called sequential. बराबर है, उस बुक में भी वैसा लिखा है. But in the industry where it is applied to design what? Sequential hardware, and that you will see 3-4 lectures down the line. You will see that. Understood? Okay. See, finally, writing Verilog and not knowing how to apply it doesn't make sense, right? You need to understand where you're going to apply this. And I'm telling you, बहुत फर्क पड़ता है. If you try and design रेज के जगह वायर लगा दिया, वायर के जगह रेज लगा दिया ना, बहुत फर्क पड़ता है. Actually, I'm telling you, your design can slow down by half the speed. I'll tell you why. Say, suppose you're wasting 1 clock every output. Means now your output is coming every 2 clocks, yes or no? मतलब हर 2 clock के बाद output आ रहा है. मतलब हो गया ना, circuit is half slow. Yes or no? वो wire और रेज का थोड़ा इधर उधर हो गया, that is the difference. You will see that. We will see that 2 or 3 lectures down the line. I'll explain to you conceptually how that happens. See, that's why I said, now what is the motto of this course? Think hardware. Have I even spoken one word of software here? अभी तक मैं पूरा हार्डवेयर का ही गाना गा रहा हूँ ना. हाँ, remember that. And this is what differentiates a good Verilog designer from an academic Verilog designer. You understand that? Okay. See, I don't take any reference book, right? Because we have been trained that way. See, I was also trained by somebody like how I'm training you. उसने तो मेरे को मार के सिखाया था भाई, think hardware. Literally मारा भी है मेरे को. Because that guy was like my guru. I did a course in Pune. At that time I learned 2004. Okay. That time मार के क्या सिखाया था? Motto क्या था? Think hardware. So मैं तुम लोग को force करके करूँगा. Think what? Hardware. Okay. Now, is this clear? So let's say if it's a wire मतलब क्या? उसका constantly कोई ना कोई उसको input दे रहा है. मैं बोला ना, वायर सिग्नल बनाने के लिए होता है, yes or no? Driving means what? Not that driving. Driving means somebody is giving you a value. I hope you understand that. Driving in digital circuits means what? Somebody is giving you a value. That value could be a 0, that value could be a 1. Make a note of this. Drive. Strong drive, weak drive. Strong drive मतलब ज़्यादा करंट आ रहा है. वीक ड्राइव मतलब कम करंट आ रहा है या जा रहा है, दोनों केस में. Drive means what? Giving a value. That value could be what? 1 or 0. The word drive means what? Is giving a value. That could be 1 or 0. So, please understand this. Okay, I'm going to pause here, or rather I'll record. Let me ask you a question. Logic 1 and 0, we are doing digital circuits, na? Yes or no? ME guys don't answer. Probably, I presume I must have asked you all on the interview. What is the difference between logic 1 and logic 0? What is logic 1? What is logic 0? Can somebody tell me? Achha, even you know that one. Okay. What current? Okay. I said that in the. Okay. Cheating. You know the answer. Okay. Now, they know it. Even you know. You're also not allowed to answer. For the other guys.
So it depends on the voltage. For example,
Now tell me and explain in terms of current. High current is flowing and low current is flowing. No. Logic 1 means you are sourcing current. मतलब you are giving current. Logic 0 means you are sinking current. हाँ, sinking मतलब ले रहा है. ठीक है, जब माइक्रो कंट्रोलर 1 देता है या FPGA 1 देता है मतलब वो करंट दे रहा है. 0 मतलब वो करंट ले रहा है. Go ask any of your faculty members this question and then Viva KT पक्का है. ऐसा पूछने का नहीं है, जाके छेड़ने का नहीं है. हाँ.
I'm just thinking, for example, let's say above 3.6 we have a 1, and below 3.6 we have a 0.
Right.
So if I go, let's say I get 4 volts,
Ah.
current, I'll create a high potential and a low potential on the other side. So
It won't create. You have to assume there is a low potential on the other side. You cannot create a low potential there. You can only create your potential. Please understand that. You can only create your potential. You're assuming that there is a low potential there, or there is a potential there who you are higher than him, which is typically 5 volts. So you're giving him current, and when you want to give a 0, you'll pull yourself to ground so that you can pull all the current back. Clear? Understood this? Yes or no? So there are 3 levels, by the way: high current, low current, and no current. Please understand this. In electronics, high current, low current, and no current. No current means what? It's neither flowing out nor flowing in. It's high impedance, tri-state. किसी ने सोचा था high impedance ऐसा होता है? नहीं ना. This is how you, because see, let me put it this way. Suppose, because 1 or a 0 at the end of the day, if it's going to give somebody an output, let's say you are driving the output of a NAND gate. You're driving the output of a NAND gate. NAND gate is sensitive to 1 and 0 both. Na? If it's a 0, that output will go to 1. If it's a 1, the output, if the other guy depending on him, the output could go to 0. Now, if you don't want to trigger that NAND gate, what do? You don't give him any current. Na? You understand that? Is this point understood? There is giving current, taking current, and not doing anything with the current. मतलब just open the gate completely. It will not, आगे पीछे कुछ नहीं होगा ना. Okay, this is just extra information I'm giving you all. Oh, हाँ.
But if one point is 0 volts and another which I want to choose is reference is 4, and if I choose less than 2.3, then current will flow from 1 point to another.
One second. Can you repeat your question, please? Once again.
If my reference is 4, above which is considered as 1 and below which is 0.
That is not defined by that is defined by the वो जो तुम्हारा जो ट्रांजिस्टर है ना, दूसरे साइड पे एक ट्रांजिस्टर बैठा रहता है. मॉस ट्रांजिस्टर का थ्रेशोल्ड वोल्टेज क्या है वो तुम्हारा 1 and 0 डिफाइन करता है. So defining reference voltages, let's not get into that. That's a VLSI question now. That's a backend VLSI question, not a front-end VLSI question. That's a backend VLSI question. For now, you assume it as this way, that when you're at 5 volts, the other guy, even if he is at 5 volts, he'll be maintaining at 5 volts. Yes or no? So then, to obviously, you have no effort to bring him up. Please understand this. Suppose he's at 0 volts. What is your job? Your job is to bring him up to 5 volts. Yes or no? So then he becomes a 1. Yes or no? Now, you want to bring him down to 0. What you'll do is you'll bring yourself down to 0 so that all the current will come to you. Suppose if he's already at 0, तो अच्छा है ना, तो 0 पे रह, मैं फिर भी अपना 0 करने का मेरा काम है. Keep it at that. Clear? Understood? हाँ. Again, 1 means what? Giving current. 0 means what? Taking current. Clear? Okay. The application of wire and reg ना हम लोग जब apply करेंगे ना तब देखते हैं. अभी difference समझ में आ गया ना कि always में the final consumer always has to be a reg. अब तक उतना समझो. we'll see the actual application one or 2 weeks down the line. वो तभी समझेंगे, ये सब डेफिनेशन उधर काम आएगा, अभी बोल के भी कुछ फायदा नहीं है. वो पूरा बाल गुरु स्वामी पढ़ के भी किसी को सी अभी तक आया नहीं है ना. Till you don't write 20-30 programs, have you ever gotten experience on C? No. We'll do that. We'll learn by doing. Just one thing. Let's see if I can find that. Okay. Suppose not A is what? What type of is it? Not A is what? Wire. Okay. If the wire is consuming, if the wire is what? Consuming, it can only be consumed using an assign statement. Assign statement which is not inside a always. Always के अंदर कौन कंज्यूम कर सकता है? फाइनल कंजम्पशन कौन कर सकता है? रेज. फाइनल कंजम्पशन. अंडरस्टूड. Suppose you want the wire to be a final consumer. You want a wire to be a final consumer, then he has to be as a assign statement. Clear? Yes or no? Understood this? There's rule. It's the opposite of the other rule, na? What is the first rule I said? That always में final consumer कौन होगा? Reg. अगर you want a wire to be a final consumer तो simple है, वो always में नहीं हो सकता है. Final consumer. Intermediate consumer हो सकता है. Intermediate consumer हो सकता है. Final consumer नहीं हो सकता. You understand that? In my always I'm doing some value calculation. Correct? Intermediate में wire को consume करने दो, कोई problem नहीं. उसका application we will see 2 weeks down the line. But final जो consumer है ना, last line, जो final value जिधर जाके बैठेगा, that guy has to be a reg. Otherwise you will not be able to use that value anywhere else. Is this clear? I'm repeating again. Inside an always block, inside an always block, if you, let me make a statement. If you make a wire as the final consumer, बनाओ, कोई टेंशन नहीं है, तुम उसको यूज नहीं कर पाओगे. बाहर, बाहर मतलब उसका वैल्यू हुआ ना, फिर in your design you will use it somewhere else. Yes or no? Understood? In your design you will use it somewhere else. वो वेरीलॉग को नहीं समझेगा. वो क्या बोलता है, अगर बाहर यूज करने का ना तो क्या बनाने का उसको? रेज. Is this clear? I'm saying it 10 times again. I hope this is clear. Final consumer, if you want to use, I put that clause now. Final consumer, if you want to use the value outside, outside मतलब design में और कहाँ पे? Correct. Has to be of the type reg. Is this clear? समझा? Guys at the back. हाँ या ना?
Is it the same case with assign? Like final consumer won't be reg.
नहीं, reg can be a final consumer in assign also. हाँ, नहीं समझा? हाँ? थोड़ा कंफ्यूज हो गया. उधर तक समझा था कि असाइन मतलब फाइनल कंज्यूमर रेज होना मांगता है. अगर रेज नहीं हुआ ना तो तू वो वैल्यू यूज नहीं कर पाएगा. और कहां पे? वो अंदर आके मर जाएगा, खत्म. क्लियर? अभी ऑलवेज ब्लॉक में यू आर डूइंग सम प्रोसेसिंग, दैट वैल्यू इज गोइंग टू कम आउट. यस और नो? वो वैल्यू को फाइनली अगर तेरे को और किधर यूज करना है, ओके, देन इट हैज टू बी अ रेज. मैंने सेम लास्ट स्टेटमेंट को खाली उसमें अभी एक कंडीशंस अप्लाई डाल दिया कि वायर हो सकता है फाइनल कंज्यूमर, लेकिन उसका कुछ फायदा नहीं है. इज दिस क्लियर? Assign is now if you want to create a concurrent statement. Now suppose this is your always block. Now you don't want to do always. This you want to do concurrent, matlab your data flow. Then you will use assign. Understood? Always will give you sequential. Assign will give you parallel. Parallel is what? Combinational. Parallel में hardware बनता है. Yes or no? Correct? Now, for today, this much is fine. We cannot finish full Verilog today. We'll cover more points next time. One last point. Okay. P is what? What type is P? Reg? Reg na? Q is what? Reg. Okay. Forget this, forget integer for now. Okay. P, as I said P could be of reg type, it can consume. Okay. Typically, let me put it this way. I'll rephrase my statement. Reg can be consumed in assign only in a very rare case. उसको छोड़ दो अभी. I said yes क्योंकि मैंने एक डिजाइन पे काम किया जिसमें होता है. For all practical cases नहीं कंज्यूम कर सकता है. वो प्रीवियस स्टेटमेंट का ऑर्डर कैंसिल करो कि in an assign a reg cannot be the consumer. A reg cannot be a consumer. Okay. In an assign, a reg cannot be a consumer. Who can be a consumer? Wire. यहाँ तक समझ में आया? You cannot. On the left hand side. We'll see different cases for now. We'll keep peeling the layers of the onion. For now, forget the assign also. Always समझ में आ गया ना? उसमें who has to be final consumer? Reg. Let's leave it at that. We'll get to the assign next time. Okay? Any questions? Any questions?
Assign the final consumer can't be reg.
Cannot be reg. Then who? Wire.
But then it can't be used.
No, it can be ना. आउटसाइड मतलब अभी मैं समझाता हूँ, ठीक है? अब ये इनसाइड आउटसाइड का क्या फंडा मैं समझाता हूँ. ये तुमने अपना now this is let's say your Verilog code. Okay, this is line number 1 2 3 4 5. This is your Verilog code. Now this is your module. You specified your module, yes or no? Now let's say you used a first always block. लिखा. You wrote some statements here. Now you produced a value here. Correct? Now you produced a value here. You are going to consume it. Let's say in an assign statement somewhere, there is a way of consuming a reg. There is a way of consuming reg, which I'll tell you. A wire can consume a reg using an assign statement. Uska ek kuch ye hai. There is a technique which I'll show you for now. So that value you have to consume here. Finally, this assign on the left hand side, you will have a wire, yes or no? अब उसको मेरे को suppose और एक कोई always statement में consume करना है, तो I can do it ना? Yes or no? So, बाहर मतलब क्या? Outside that block, but it is still in the big design ना? This creates one piece of hardware. This assign statement will create one more piece of hardware. This always will create third piece of hardware. Correct? All of these hardware are what? They are parallel. समझ में आया? Let me repeat. ये always statement made what? It will make a sequential hardware SCQ1. Yes or no? I'm using an always typically for a sequential hardware. Everybody following me till here? I'm going step by step. समझ में आ रहा है क्या? हाँ. Assign ने क्या किया? Combinational hardware बनाया. Yes or no? ये third always ने क्या बनाया? Sequential hardware. SEQ2. SEQ1, COMB1 and SEQ2. They are three pieces of hardware, but still they are what? Parallel to each other, na? Understood? Hardware at the end of the day is parallel. Yes or no? Can I use the word concurrent? Concurrent is as good as parallel, na? Matlab, from the meaning perspective. Yes or no? Now the correct word is what we use is concurrent. That any HDL, please make a note of this statement. Any HDL will always give you concurrent hardware. Will always give you what? Concurrent hardware, which is a combination of sequential hardware and combinational hardware. बराबर? इसका भी विजुअलाइजेशन बनाते हैं. क्या बनाते हैं? विजुअलाइजेशन. लुक एट दिस. दिस इज ऑलवेज. इट विल गिव मी सीक्वेंशियल हार्डवेयर। नाउ ये ऑलवेज का वैल्यू, ठीक है, एक असाइन स्टेटमेंट ने कंज्यूम किया। लेट्स से वो मक्स वाला कोई स्टेटमेंट, एक मक्स वाला हम लोग ने कुछ लिखा ऐसे कुछ, ठीक है। सो दिस इज गिविंग यू व्हाट, combinational hardware, yes or no, right? Then I write another always, this gives me what, sequential hardware, correct? Now ऐसा हो सकता है ना, इसका वैल्यू बना हुआ यहां पे कंज्यूम हो रहा है, yes or no? What will be the hardware visualization? इसका आउटपुट इधर आया, इसका आउटपुट इधर आया, और इसका आउटपुट फाइनली इधर आ रहा है। ये पॉसिबल है, हाँ या ना? करेक्ट। All of these three pieces of hardware here, here and here, they are all concurrent in nature, yes or no? Although my Verilog code is written in a straight line, but the hardware that is made is what? Concurrent, yes or no? Everybody is following me here? पक्का समझ में आया? ये फंडामेंटल है वेरीलॉग का, रिमेंबर दैट। कभी भी सिखाएगा ना बच्चे लोग को, याद रखना कि एट द एंड ऑफ द डे लाइन अपन लोकल ट्रेन की तरह लिख रहे हैं। सी प्रोग्राम इज नॉट लाइक दैट। सी प्रोग्राम विल ऑलवेज गेट एग्जीक्यूटेड सिक्वेंशियली। HDL इज नॉट दैट वे। HDL में each piece it gives you parallel hardware. Now in that, sequential statements will get executed what? Sequentially. Sequential statements here inside this always block will get executed sequentially. Why? Because you want to create what? Sequential hardware. आप बोल रहे हो ना executed sequentially, ये सब statements कहाँ काम आता है? प्रोग्रामिंग में। इसका अपना काम क्या है? ये HDL से अपने को क्या डिजाइन करना है फाइनली? हार्डवेयर। उसमें एग्जीक्यूशन का धंधा ही आता ही नहीं है ना। हार्डवेयर तो will operate, it will not execute. You understood this? So sequential statements are used to describe sequential hardware. Assign concurrent statements are used to describe combinational hardware. Finally, all of them exist what? Concurrently. Yes or no? Is this clear? 100%. ये विजुअलाइजेशन बहुत ये समझ में आ गया ना, ऐसे एक्सप्लेन किया तो? Agreed? पक्का? Now, whenever you will write any HDL code, my favorite midterm question, किधर गया? क्या नहीं, इसको पता रहेगा। My favorite interview question is, no problem, you don't need to call him, it's fine. My favorite exam question is, this is the code, draw the hardware. पक्का क्वेश्चन, ये गारंटीड लिख के देता हूं, आएगा ही आएगा कि ये कोड है, इसका क्या हार्डवेयर बनता है। तुम लोग थोड़ा अपना दिमाग खुजाओ। उल्टा ये भी हो सकता है, आई विल गिव यू अ हार्डवेयर ड्रॉन, राइट द वेरीलॉग कोड फॉर दिस। I will make sure you will visualize hardware. Understood? Clear? Okay. That is end of display for today. Clear?